Welcome back, coders. It is time once again for the Ultimate Node Stack 2023 edition. This is my third year rather, I should say, to do this video. I started this in 2021, did a 2022 update, and now it is 2023. This video is for you if you are looking to develop in Node.js using Postgres, hopefully combining that with some Docker to get a really nice development environment. The benefit of using Docker, really, in my opinion, in development is that it helps you mirror production more, your production environment. You can add in tools like Redis and other things that you might need, and then make it very easy to deploy to production. And if you're someone like me who works on a team where we're switching between different projects, some projects have different versions of different things, Docker makes it really easy to get in and get out of different projects and different versions. I see some comments coming in already. I'm live. This is one of the earliest videos I've scheduled. I scheduled over a week in advance. So thanks for tuning in live. If you have any questions, post them here. I'll try to monitor this as we go. Let's do a quick rundown of what is in the Ultimate Node Stack. So of course, we're running everything on Docker, and specifically Docker Compose. We'll use a Docker Compose file to set up our Postgres and Node instances. We'll be using Postgres for our database. We'll be using Node, of course, to run our JavaScript, but not quite our JavaScript, our TypeScript. I'm a huge TypeScript fan, converted fully over to TypeScript a couple years ago. Even if you're not using TypeScript, if you're just using JavaScript, this is still going to work great for you. We're using PNPM. So this is actually the biggest change from my 2022 version. 2021, 2022, we used Yarn. I've been a big Yarn fan throughout the years, but PNPM seems to be what the cool kids are using. And it's also very fast, and as they say, disk space efficient. So I've been using PNPM in some more recent projects, and I have to say I do really like it. At first, it was a challenge to get running in Docker, but then I realized with one simple way, it's actually pretty easy. We're going to be using SWC to compile our TypeScript into JavaScript, to build it into JavaScript. SWC is super fast. Hi from Luxembourg. Thanks for joining. We'll be using Prettier to help format our code, because that's nice. We'll be using Prisma as our database ORM to connect to Postgres. And perhaps most controversially, I'm actually using a different ORM for migrations. I happen to really like the Knex migrations library. I really like scripting the migrations in JavaScript. Alternatively, you could use the Prisma migrate feature. And finally, for our web server, we'll be using Express, because it's the tried and true that everyone has been using for years. Like always, we're going to be doing this from absolute scratch. So this is going to be from scratch. Even if you don't do it from scratch each time, it's helpful to see all of this come together. And it is quite a few pieces here to put together, and so it's helpful to understand how that goes. But because it's so many moving pieces, I do have a couple of resources to point you to. First is a blog post that I actually also put out each year. It's called The Ultimate Node Docker Setup. Very similar to this video title. You can find that in the description below of this video, and that's already there here even in this live stream. I published this today, so you can go ahead and pull that up. There's also a sister GitHub repository of this that I also pushed the latest 2023 updates to today as well. So if you want to follow along for yourself, then this blog post is going to be a great way to do that. In fact, I'm going to be referring to that on the side here throughout this video. So let us jump right in, shall we? Okay, let us go. Let me set up a couple of things here. I think I've got, don't have any questions yet, but everyone said hello. Hello. So let's get going. Like I said, the biggest change is switching to PNPM. Oh, the other big change in this video is the way we're doing database seeds. Database seeds is a way to populate your database with some sample data for development. And we did that kind of a weird way in 2022. We're going to do that a bit more reliably, or a different way here in 2023. So we'll go over that. So let's jump right in. Let's get started. And we're going to start at our command prompt with no code. So we're going to start from scratch, actually just going ahead and making a directory. So I have a folder here that I put everything in. So let's make a directory. We'll call this ultimate node stack. I'll cd into this directory. And actually, I think from here, I just want to use VSCode. So I'm going to go ahead and open this in code. All right, I'm going to use, on the Mac, it's Control tilde to open up a terminal. So I'm going to go ahead and do that. And the first thing we're going to do is initialize this directory with p&pm. Now, if you don't have p&pm or, let's see, if you don't have p&pm or something called Volta installed, I want to recommend this to you. I'm not going to go over installing this in this video, but Volta, if you get anything out of this video, this is a great tip. Volta is a great way to manage node versions on your machine. Especially, like I said, if you're switching between projects, this is a very easy way to switch between node versions on your machine. So get Volta. We're going to use Volta a bit here. You'll see in a minute. So let's use p&pm to initialize this directory. And what this is going to do, p&pm init, let me make this a bit bigger for you. p&pm init is going to just create a baseline package.json for us. So I didn't even pass it any arguments. This is just going to create a skeleton package.json for us. And then with Volta, one of the features of Volta is we can pin a specific node version to this project. And what it will do is anytime we switch into this directory for this project and try to run anything using npm or p&pm or anything like that, or node, then it will automatically use the correct version for us. So let me do Volta pin node at, and I'm going to do the latest node, the latest LTS node, long-term support node, which is currently version 18. So if I just do Volta pin node at 18 here, you can see that adds this Volta section to package.json, which will be nice. And that's kind of a way for any fellow developers working in this project, it can help them use the same version. Claudio says Husky can be a good fit as well. I actually haven't heard of Husky before, so I'll have to look into that. Okay, so we have our package.json baseline. We've got our node version there. So let's go ahead and start with some TypeScript. That's always a good place to start. So I'm going to p&pm add TypeScript here. So this will add the TypeScript dependency to our project. And one of the first things you want to do with TypeScript is just make sure you have a good baseline config set up. There is a really helpful package that is, what is it? tsconfig/node and then whatever version you're using. So this @tsconfig/node version is a collection of tsconfig base configurations. So you don't have to do like every single thing to configure tsconfig from scratch. This is going to give you a really good base set of configurations to start with. And I use this on pretty much all projects. So I'll show you how this works. So I'm going to pull in this command from the side here. So I'm going to do p&pm add --save dev, because we're going to put this in dev dependencies. And we'll do @tsconfig/node 18. So that's going to add this to dev dependencies. And then what we can do is create a new file for our tsconfig.json. And this is always kind of scary, like starting this thing from scratch, because there's a lot of configuration options. But the cool thing is we can say extends here, and we're going to extend tsconfig/node 18/tsconfig.json. And you'll see here along the way, I do have Git Copilot running in the background which is always very helpful. So if you're following along in the blog post or anything, we do have a couple of other options that I like setting in tsconfig, not the ones that Copilot is showing here. But let's do compiler options. And then we want to set a couple options. First is our lib. So we're going to say that we're using ESLint. So we use the kind of the latest flavor of JavaScript and APIs available. And then I want to set our out directory, so where any of our built code gets outputted to. And I do like calling mine dist for distribution. So then let's do include. And I do a similar to this, just a source folder. So we're going to create a source folder here in our code base or in our repo. And so that'll be where we house all of our source code. And then finally, only one other thing here. We will exclude node modules, and then we're also going to exclude anything that has test.ts. Now, we're not going to be writing any tests in this video today, but if we did, we don't want to include those in our distribution build. So, fairly straightforward tsconfig. A lot of the real meat of this for configuring TypeScript for Node is going to come from our tsconfig Node 18 base that we have here. We're just setting a couple of different options to set our input and output directories, build, everything like that. So that's getting tsconfig set up. Now that we have that, let's go ahead and start our first source file so we can see this work or perhaps blow up along the way. So let's just create an index.ts file here, and we'll just say console.log/hello world. So if I save this, and really even before I save, you can see we already have some red squigglies on our first line of code. Well, that's because we need, since we're working in a TypeScript environment, we need to make sure we have all of our types available. And there is a package for node-specific types like console. So we can add that in here too. So let me do pnpm add --save dev @types/node. So @types is something you'll see pretty commonly. That's from a group called Definitely Typed, I believe, which is a large collection of community-supported types for all types of packages in the Node ecosystem. So as soon as I add this here in a few moments, yes, you should see those red squigglies go away. So @types/node pulls in the TypeScript types we need for these Node APIs. All right. Now the next thing is we want to make sure that since we're working in VS Code here, that VS Code is using the same version of TypeScript that we're using for our development and that is saved here in package.json. So I'm going to show you two different ways to do this. First, from the GUI, from the UI here. If you have a TypeScript file open, you can actually click on, I believe, you can click on TypeScript down here. Okay, yes. Okay, so you click on the little curly braces beside TypeScript, and we can see there is a select version here. So I'm going to click on select version. And instead of using VS Code's version, because I don't care what version VS Code has, I want to use the version that I've installed in my package.json. And that is this workspace version. You can see it's getting it from no modules/TypeScript. So earlier when we added TypeScript to our package.json, that's installing a very specific version of TypeScript, and we want VS Code to use that same version. Now that's all nice for the mouseketeers who like to use their mouse and everything, but what if you wanted to know what that config actually did? Well, what that's done, what VS Code has done in the background is create a .vscode directory for you in the root of your project here and created a settings file. And it has set the settings called TypeScript TSDK of which TypeScript version to use. So you can either create this file yourself, that's just as good, or you can use the GUI. Okay, so we still haven't actually run anything yet. So let's move on to our code compiler, our code builder, in order to actually compile this into JavaScript and run it. So like I mentioned, we're going to use SWC. SWC is an awesome compiler. It is super, super, super fast. So there are a couple of different packages that you'll want to install here. So let's do pnpm add. Again, we're going to do this into save dev. And I'm going to install @swc/cli, @swc/core. Those will be the two SWC packages we need. And then I like installing a package called rimraf. This is kind of a utility package to help you do what in Unix world would be rmrf, to just completely wipe out a directory. And the nice thing about using this is it works cross-platform. So if you've got Windows folks working on this project too, and you want to delete a directory, then this will work in the Windows world as well. So let's go into our package.json. And I want to add a script in here for how to build our project. I'm just going to remove this test script for now. So let's create a build script, and what we'll do is we'll do rimraf. You are correct, GitHub Copilot. Rimraf dist. So we're going to wipe out a dist directory if that exists. And then otherwise, we want to run our SWC compiler on our source directory and output that to the dist folder. D is for destination. So we have our build script here, but SWC comes with some configuration as well. Now, technically, SWC works out of the box, and it's designed to do so. But to really get it to do what we need to do, we're going to add some configuration there as well. Again, if you don't want to hand type all this configuration, you can find it in my blog post link down below or in the GitHub repo link down below. But we're going to go through this each line so we're all on the same page about what it all does. So first thing we're going to do is configure the SWC environment here. And what that means is we're telling SWC what version of node that we want to target as far as APIs and language features, really, of what's available. So we're just saying we're targeting node version 18. And so already we can see side by side here, using Volta, we're pinning which version of node is working in here, and then using SWC, we're specifying which language features we wanted to compile down to. Next, for the actual compiler itself, or parser rather, we're saying that we're using Typescript. So we're going to do syntax, Typescript here. Perfect. Now, what type of modules? ES modules seems to be the direction the ecosystem's going. If I'm being really honest, I've tried so many times to make ES modules happen, and I just can't make it happen. Yeah, I run into issues every single time. So I'm still trying to get there, but getting all these pieces working together, for me in Nodeland, I'm still using CommonJS. So I'm specifying here that the module type of this project is CommonJS. I tried in my prep for this video to make ES modules happen. Still's not happening. There's still quite a few rough edges in there getting your ecosystem to work together. And then finally, the last thing we're going to do is we're setting a source maps option and setting that to inline. What this is going to do is it's going to, when it's compiling from TypeScript to JavaScript, it's going to set up some source maps actually embedded inside the file. And that's going to help us when we get to working on debugging. Because we really want to be able to debug our code using our rich debugger tools that we have in VS Code. But because it's going to be running in Docker, there's a little bit of hoisting and setup to get that to work. And the source maps inline feature is a very key configuration in order to make that work and make that happen and allow us to debug something in VS Code that is actually running in our Docker environment. All right, so let's keep going here. Let's add, so we've configured SWC. Let us add a script to start our project. So we're going to do exactly this. So our start script will be running plain old node, running the index.js file, which is created by SWC when we build. All right, so we've got TypeScript, we've got SWC, we've got a build script and a start script, and we have our first source file, which is a simple hello world. So let's see if at this point we can build and run this project. So actually, let me pull this back up so my face is not covering the command line here. So let me do a pnpm build. Successfully compiled one file. So we can see we do have a dist folder. We do have an index.js. And you can even see the source maps at work here inline here in the file. All right, so that works. So let's see if we can do a pnpm start. And we do, in fact, get hello world. So we're doing pretty good so far. Great. This seems like a good time since things are working and we've kind of hit a good little milestone here to start up a GitHub repository for this project that we're working in. So I'm going to go in here and I'm just going to say git init, and that will initialize a Git project. Oh, and it looks like I haven't set my default branch name. So I'm going to set my default branch name just globally to main. And you know what? I'm going to revert and start over here git-wise. So I'm going to do an rmrf my .git directory, which is where all your Git files are stored for this project. I'm just going to wipe that out. So let me do this again now that I've configured my default branch name. I'm going to do git init. So now it has initialized the Git repository for this project. And if I go over to VS Code here, we can see that, we've got like 2,000 changes already. Doesn't seem like that much, but it's because it's including everything, including our node modules. So one of the first things we need to do is create a .gitignore file to tell Git what we don't want it to check in into the GitHub repo. So let's create a file that's called .gitignore. And the two things we want to include in here are dist. So we don't need to include our code builds. Whichever machine is running the code will be responsible for building the code. And then we're going to include node modules here as well. So again, whatever machine is building the code will be responsible for installing its own node modules. So we can see our changes so far from scratch are now just 7 files. So that makes a lot more sense. So we do want to check in the .gitignore file. We do want to check in the SWCRC file. We do want to check in package.json. You do for sure want to check in your pnpm lock file, your tsconfig, even your VS Code settings. Anything that is shared across your team, even VS Code settings like this, are good, and then our source file as well. So I'm just going to call this initial commit, and we will get there. All right, moving right along. Next up, we're going to set up ESLint. So ESLint is a great way to make sure you're following along with best practices, and again, if you're working on a team, for everyone to kind of generally be following the same rules and principles. This is a long one, so I'm gonna paste this in here from my blog post. But essentially what we're doing is we are adding a few different packages into dev dependencies, so with this --save dev here. Adding ESLint, TypeScript ESLint plugin, and TypeScript ESLint parser. So we're using ESLint, but the TypeScript flavor of things, because of course we're coding in TypeScript. TSLint used to be a thing, but it is no more. People recommend using ESLint now. So much like other tools that we're incorporating into our project here, they come with configuration files. So let's do ESLint RC, and again, this one's a little bit on the hefty side, so I'm going to paste this in from my blog post as well. So what we're doing is we are starting with the recommended configuration from ESLint and Typescript ESLint. Because there are so many community-supported tools now, especially with switching between projects, it's really nice to stay as much to the defaults and recommendations as you can, so that every time you're switching between different projects, you're not switching between everybody's different flavors of what they like. I'm going to break that rule here in a little bit with Prettier, because I have one thing I can't get rid of on Prettier. But as far as ESLint goes, I just go with the pure recommendations. So from the ESLint package, we're going with the recommendations. From the TypeScript ESLint package, we're going with the recommendations. We're setting the parser to the TypeScript ESLint parser, and then including the TypeScript ESLint plugin as well. Now, as far as building the code or any sort of command line things here, I'm actually not incorporating ESLint into that. I'm really just utilizing VS Code to alert me of any ESLint problems. So if you're not using ESLint, then you would want to look into making this a part of your build scripts or something like that, or a git commit hooks, things like that. And we'll get to VS Code here in a second. All right, so next up is Prettier. So again, similar to ESLint, of course, we have a Prettier RC configuration file. For most people, just a simple 2 curly braces will do. That'll give you the default configuration for Prettier. Now, there's one thing that I just really like. I can get over it if I really need to, but I just like single quotes. I like single quotes. It's my thing. If another project that I'm a part of is not using single quotes, it's not the end of the world. But this is really like the one little customized configuration I like to do for linting and prettiering, is I like my single quotes. That's just me. Okay, so we have ESLint and Prettier config setup, but like I said, we're leaning on VS Code here to help us lint our files as we go, show us any problems with red or yellow squigglies, or showing up in our problems tab before. Oh, look, we have no problems. That's a great place in life. We're also leaning on VS Code to format our code upon every file save. So if you're using VS Code, excellent. If you're not, then you would want to look at the docs here to see how you would implement this from the command line or in your editor that you're using. But like I said, if you're using VS Code, there are 2 good extensions that I recommend. You likely already have installed. But in case you don't, and in case anyone on your team doesn't, then you can create in your .vscode directory an extensions.json file, and this is a place where you can add recommended extensions for this project. And this will, when someone opens up this directory in VS Code, alert them and ask them if they want to install the recommended extensions. And so there are 2 recommended extensions that I'd put in here so far, which is this, I won't attempt that name, but is this VS Code ESLint extension and this Prettier VS Code extension. The ESLint one will run ESLint as you're working throughout your project to alert you of any issues. And the Prettier one will save and format your code upon save, which is super nice. So for instance, if I go in here and for some reason I wanted to format my code really strangely like this, just hitting save will reformat my code as according to Prettier. I've been using Prettier for years. If you haven't been using Prettier, it's really nice. You kind of actually get into this mode where you almost type things as unformatted and messy as possible, and you just get used to hitting save, and it makes it all better. Okay, so we've done a lot of configuring so far. We've gotten our SWC, our ESLint, our Prettier, our TypeScript, our tsconfig. We've gotten extensions. We've got building. We're running. We haven't really done any coding. So let's do some coding. Let's actually pull in Express. Let's start a web server. Let's get something running more than just hello world. So let's first add Express. So we'll do pnpm add Express. And then it's always nice to have some sort of logging mechanism so you can actually see what's happening. So I like a little logger called Morgan. So we're going to add that in. Now, neither Express nor Morgan come with TypeScript types. And so we're going to install the types from the community. So we'll do pnpm add, and usually when you're installing types, you just want to, those are really just for development purposes. So you can save those to dev dependencies. So we'll do @types/express and @types/Morgan. All right. Okay, so I've pulled open our index.ts file here in the source directory. And let's get to writing out our basic web server. So first thing, let's import Express from Express. And let's create an app from just the function Express. And right at the top, let's go ahead and add our logger into this. So let's do app.use, and we're going to do Morgan. And Morgan has a couple of different formats to how it logs. And one of the more useful ones is this dev format. Now we don't have Morgan right here. Sometimes a nice little control space, VSCode will install that import for you, and then sometimes it won't. So we'll import Morgan from Morgan here. So now let's add a handler. GitHub Copilot is way ahead of us. AI is going to take over, right? So let's do app.get, and we'll just pass this a string with / in it. So this is the GET request of the root route. And we're going to do a response.json. So we want to return some JSON, and we're just going to say hello world. That looks good there. And then, so this defines our app, defines a route handler, some logging in there as well, but we still need to start the server. So let's do app.listen, and when we listen, we provided a port. I'm gonna make that a variable. So we're gonna put that on port. Now, usually, if you aren't used to building in Docker, what you might go ahead and do is just do a function here, which is a callback, and log something here. But there's this interesting little oddity of Docker, which is you need to run things not on localhost host, but on 0.0.0.0. So you'll want to add in this second argument here, which is the host argument, and make sure you're running the server on 0.0.0.0. And this applies to development, it applies to production, it's attaching it to a specific host inside the Docker container. Now, what port are we doing? Let's actually do something very similar to this. We're going to pass in an environment variable of port. Otherwise, let's do some sort of default port. And I'm just going to do 8080 as a default port. That's a nice default port, especially for a server environment. And I'm actually going to cast that to a number. So instead of this being a string, which is what environment variables always are, even if you set an environment variable to a number, it comes across as a string. So I'm casting this port, which is a string, or this number. Either way, it's going to end up as a number. And we'll use that here. And then I'm just going to say something like server listening on port such and such. And I'm going to add in our localhost there as well. Okay, so that is a bare bones, basic Express server. Let's see if we can run it. First, let's just do pnpm build, pnpm start, and it's working. So let me do gonna open up another tab here. Let's do a curl HTTP localhost 8080, and in fact, we are getting hello world back. So while that's nice and fun and exciting, hey, pat yourself on the back, this is not running in Docker yet. So this is running on our local machine. We've proven our code works, but this is not actually where we're going to run our code. We want to run our code in Docker. So I'm going to Control-C out of this running server, and now's the time for some Docker fun. So let's begin configuring our Docker, and this is going to be in two pieces. We're going to configure a Docker file, which is how we're going to build up the node image that's going to run in Docker. And then we're going to create a Docker compose file, which is going to specify our various Docker services. So let's start with the Docker file. And Dockerfile is just called Dockerfile. Nothing else. So we're going to start with from, and we're going to start with a base image. So what's nice is there's a base image just simply called node. But there are some kind of parameters or it's called tags, or some tags we can apply to this to get some sort of specific node images. So because everywhere we're specifying use node 18, or whatever version of node you'd like to use, then we can say :18 here. And that will help us to make sure that we're running node 18. Now, for many different use cases, you could even say -alpine. And that would get you a very thin, streamlined version of Node running on Alpine Linux, which is very popular in the in the Docker ecosystem because it uses fewer resources. In our case, I'm just going to use the basic Node package, or Node 18. We're going to end up using Prisma in this setup, and Prisma doesn't come out of the box working with Alpine. That takes some special config. You can do it. But we're going to keep things a bit simpler today. So I'm just going to use node 18 and call that good. Now, next up, throughout this, we want to use pnpm, not just npm. So at first, I went round and around like, how does this work? And did lots of Googling on this. Turns out it's quite simple. We're just going to use npm to install globally pnpm. That's it. And so this might have been what you did on your local machine to get pnpm running. And in fact, I didn't cover that at the beginning of this video, but that's one of the ways you'll see in the pnpm docs of how you can get pnpm going. So that's it. Now that you've used npm to install globally pnpm, you can use pnpm in your Docker environment. So let's create a work directory, and I usually make mine user source app. So that specifies where we'll be working from here on out. And the next thing we'll do is that. We're going to copy in the minimum set of requirements, or minimum set of files that we would need to install our dependencies. So what this is doing is it's saying we're going to copy the package.json file from our project here and our pnpm lock file into the root of our current working directory. The reason we're copying a minimal set of files is the way Docker builds images. It builds it one line at a time. And at the end of each line, or at the end of whatever's running in each line, it caches the result. And so it doesn't have to actually run this every time if nothing changes. So if our package.json and pnpm lock file don't change, it can actually use the cached result of this. So as you're building up your Docker files, if you're doing something, you want to do the minimal set of changes on each line so that the caching runs really, really nicely. So now we're going to do npm install, but along with that, we want to use this frozen lock file flag. And what that does is sometimes when you do npm install, depending on if things have changed, some version updates, like there are a few different cases where it could actually change your lock file. We don't want it to change our lock file, not when it's building for Docker. So we're going to say consider the lock file frozen. Next up, we do want to copy in the remainder of our code. So everything else, not just our source directory, we do want some other things in here. Now we don't want everything. We're going to ignore some things. We'll go over that next. But aside from the ignored items, we want to copy the rest of what's in here in. Next up, we're going to expose a port. So we're going to expose 8080, which is the default port that we set in here. And then finally, we want to run a command. So we're going to run the npm start command. Now, this is kind of a funky syntax, but essentially it is every word that would be separated by a space, you kind of make an array here. I'm sure there's great reasons for this. To be honest, I don't know them off the top of my head. I just do as I'm supposed to be doing. So that is our Docker file. This is what defines how we're running this. Now, this is the Docker file that we'll be using in development. Frankly, this would be a fine Docker file to use in production as well. But you can make multiple Docker files if you want to tweak things between development and production. Okay, so that is our Docker file, but a very important item in here is this copy ... What this is saying is copy everything from the current directory into the Docker build. Now, we want everything but. We want everything except a few things. So much like our .gitignore file, we're going to create a .dockerignore file. And that will tell Docker to, when you have commands like copy everything, it's going to ignore certain things. So we're going to ignore some things here. One is called pnpm store, .pnpm store. Excuse me, I should say. This is a kind of a cache directory that occurs, it kind of just appears sometimes with pnpm, so we don't want to copy that in. We also don't need anything in our .vscode directory. Docker doesn't care about our .vscode extensions or settings or anything like that, so we don't need that here. We don't want to copy in our dist directory. So when we're putting things in Docker here, we're actually going to build it with Docker, and that will create inside of Docker the dist directory for us. And the most important one, perhaps, is node modules. We definitely don't want to be sharing the node modules directory with our own machine. In my case, it's a Mac. For you, it might be Windows, with what's running in Docker, which might be Linux or Ubuntu or whatever, because different things need to build differently. So you don't want to share node modules in there as well. So that's some good configuration to have in there. So let's get to configuring our Docker Compose now. So we have our Docker file. That just tells us how to build our node image, but we're going to want a database as well. So let's create what's called a Docker Compose file. Docker Compose helps us to compose several different services running together. So this is the YAML file, so docker-compose.yml. And it starts with a services key. And then under services key, I'm going to create a service called backend. Now, services is a part of the Docker Compose spec. You have to use this word. But backend is whatever you want to call it. So this is going to be what you want to call your service running in Docker Compose. Now we need to either give Docker Compose an image to build, or we need to give it a Docker file. So I'm going to just say build the current directory. So it will go find the Docker file, its instructions for how to build the thing in our current directory. Next up, we want to open up some ports between the Docker image running in Docker and our local machine. So let's say that we wanted to run things on, I'm not going to use 8080, I'm going to use port 5000. So we're going to map port 5000 running in Docker to port 5000 running our machine. So when we open up our Chrome or we use curl or something in the terminal, and we curl port 5000, it's actually going to forward that port on into what's running in our Docker image. Next up, there's a very special important port, 9229, that you're going to want to map between your host and your Docker running machine. And I like adding a comment in here so people in the future, for posterity, know why this strange port is in here. And this is for debugging. So this is the port that VS Code or your Chrome inspector, or anything else that you may be connecting to your node process to for debugging sake would use for communicating with the debugger. So that's good. Helpful to leave that comment there. Next up, we're going to set some volumes. So first volume is Copilot's getting ahead of me today. First volume is this very important syntax where we have two paths separated by a colon. This is saying I want to map my local machine's current directory to this specific directory in Docker. Let me pull open my Docker file here. If you remember, we are putting all of our code and we're running from this user source app directory. I'm doing the same thing here in Docker Compose. What this does is anytime I save a file here on my Mac, it's going to instantly be available in the Docker image. So that's going to help me from, I don't want to rebuild this thing every time I change my code, like rebuild a Docker image, that would take forever. So we're just linking these two directories so that they update with each other. Next up is we're going to create a volume user source app node modules. Now you'll notice there's no colon here because we're not mapping something from our local machine into Docker. We're just saying that Docker, this node modules directory inside of Docker, is its own thing. We do not want it to be mapped or interact with our local Mac or Windows machine. So this helps the node modules directory running inside of Docker be completely separate from our Mac one. Now there's another one in here that I'm going to go ahead and create. It's only applicable sometimes, but I'm going to go ahead and specify that PNPM store should be its own sort of thing, its own sort of cache or whatever it has in there. Shouldn't interact with our Mac. So those are our volumes. Next up is a command. So by default in your Docker file, it is going to run pnpm start. Now what we really should be doing in here is some building, and in fact I'm a little surprised I don't have that in here. May want to add a build script in here, but what we're going to do is instead of just starting, when we're in our local development environment here, and Docker Compose, by the way, just for development. This is not something you would use in production. So Docker Compose is just for your development sake. We want to run, when we're running the backend service, we want our special command. So not just pnpm start, because every time we run our backend, I really want to build and start it at the same time. So we're going to create a special command here called pnpm start :docker. And that's something that we're going to make. So let's make that right now. So I'm going to pull up package.json, and kind of like start here, I'm going to do one called start docker. And what this is going to do is run both pnpm build and pnpm start. So that's just a convenience script, I might call it, to both build and start at the same time or consecutively. So what this is doing is overriding the command that we're using in the Docker file to start this thing. And then finally, we want to set some environment variables. Actually, just one for now, I think. This one's going to be called port, and we want to specify a port. In this case, we're using port 5000. So you can use any port you want. You just have to make sure you change it in this place, and this place. These 3 places. So this is saying that we're using port 5000 across the board. And again, that will end up overriding the port that we've specified in our index file here because it is pulling it from the environment first. It's only falling back to our default port if we didn't specify one. All right. Okay, so let us see if we can run this thing. Is now a good time to do that? I think we should. Okay, let's see if we can run this thing. So I'm going to pull up my terminal here. I'm going to delete one of these. I'm going to check the chat for any chats or questions. No questions so far. Okay, great. So let's do a docker compose up. Excuse me. Let's see. Permission denied while trying to connect to Docker sock. Blah, 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 blah. Okay, let's see what's going on here. Am I running Docker? Dismiss. I'm not sure. Restart. Permission denied while trying to connect. Containers. Well, that's a new one. Okay, let's see. This is still starting up. Let me see. Let me see if I just needed to restart my Docker real fast. Okay, Docker has started up here. It looks like we're not running anything. Okay, so let me do a Docker PS, just see if we can communicate with our Docker. And we can't communicate with our Docker right now, so something is happening. That is a new one for me. Let's see. Connect permission denied. Let's see if we can add, let's see if this works. Okay. Well, folks, this is a new one. This is live coding for you. I've done Docker several times on this. What can it not find here? That is tricky. Let's see if I can connect to it in iTerm. Same thing. Okay, so if you're watching the recording of this, skip ahead. Hopefully I've figured this one out. But we're going to figure this out live real fast. Hopefully. Cross your fingers. Okay, got permission denied. 1 second. Running this through the Googler. Let me quit Docker Desktop completely. and restart this. I don't think that's going to fix it, but I'm going to do that while I keep looking here. I don't know why that would be running. Okay, let's try Docker here. Okay, looks like it might be mapped to a different user on this machine, which it has not done before. I'm going to reset this real fast and see if that will fix this for me. Yeah, I think I actually did update Docker. So I use Docker for Mac to run Docker on my machine, which has been very handy, really awesome. I think I did had a little update for it today, so I ran that. But I ran that on a different user on this machine. I have a different user for my channel here for coding, and for some reason, those are different. So let's see what this is. That's still mapping to my other user here, which is odd. So I think that this is still going to not have access to that, yeah. So do we have Docker machine? Yeah. Well, I know the way I think that the tried and true way I think I can get this to work is to reinstall Docker on my machine live here, which does not sound like fun. I can also try to continue searching docs for this, but I don't want to waste your time. Again, if you're not watching live, just skip ahead. Hey, Bruno from Brazil. Thanks for tuning in. But what I am going to do, I'm going to see if I just redo this, move this in, replace. Docker's in use. Okay, Docker's quitting. Gonna try to move this in, see what happens. Otherwise, this could get a little hairy, but we're gonna try to figure this out. I feel like I've said this in several videos, but it's like, this is not the issue I thought I was gonna run into today. Usually Docker's the easy one. Running in Docker. Could have been some code bug I couldn't figure out. Okay, so we've copied this into applications. I don't think that's actually going to reset any settings. But let's see what happens. I'm sure. Skip. Okay, let's see if that for some reason magically, it did not magically. Yeah, I don't think this is going to fix it. Okay. If I could probably do this and get away with it. Oh no, I can't even get away with that. Interesting. Oh my goodness, y'all. Do they have some sort of like, I thought I was doing like a hard reset. Okay. Let me do this. Doing uninstall. Aha, okay. Let's see if we can uninstall this and install it back. So like I explained, I have two different users on this machine. One for like my day-to-day work, and then one for coding on this channel. And never before today has this been an issue running Docker in either user. So this still has some sort of mapping. Okay, what I want to do is before we install this back, I want to remove this. Hopefully I don't regret that. Okay. All right. Accept. Okay. Use recommended settings. All right. All right. We're skipping the survey. We're starting the engine. Okay. Okay. This is reassigned back to this, my current user, which is called Coder. That is very strange to me that that is now per user. I'm going to need to look at that after this video and check that out. But I've never had any issues running Docker from multiple users on this machine. So now if I do a Docker PS, I think this will work. Yes, that will work. Okay. If you're watching live, thank you for tuning in to this live, not so much debugging as just throwing things into the flames and reinstalling them. Okay, so we have Docker running now. If you've skipped ahead from the recording, thanks for tuning back in. Okay, so we have Docker running now again. So what we're going to do is we're going to do a Docker compose up, and we're actually running. Okay, okay, whew. Close one there, y'all. Close one. Okay, so Docker compose up, what are we doing? So what is happening here is Docker is attempting to start up all of these services, which is one that we have defined here in Docker compose. This one service called backend that we have is building the current directory from this Docker file. It has never built this Docker file before, so it's going to go out and build this image. So it's going to start by downloading the Node 18 base image, and then like I said, it goes line by line through that Docker file, following each one of our steps until finally it gets to the bottom and everything is built. And since we're running this from Docker Compose, it is using our special command that we've created called start Docker, which both in one go, start Docker will both build and start at the same time. And as we can see here, server listening at localhost 5000. So it has in fact built and started. So if I hit option click this and open that up in a browser, we can see in fact, hello world. So if I'm doing localhost 5000 here, it is mapping this 5000 port into our Docker image thanks to this ports mapping here in Docker and Compose. We're getting hello world back from our Express server that we're running right here, returning JSON. I can't believe we got, so glad we got through that Docker issue. We can continue on now. All right, what is next? Lost my place here, troubleshooting Docker. Okay, so we have started this for the first time, but let's say we make a change. So let's say instead of saying hello Kevin, we say hello YouTube. I hit save, I refresh here, no changes. Even if I like Control-C out of Docker Compose and Docker Compose up again and I refresh, it does in fact say YouTube, but that is because it is building and starting at the same time. So that's what I expected. But every time I make a change, I don't want to like come in here and restart the server. That's just a lot of work. I'd rather just save and have the server restart in the background. So what we're going to do, what you may be used to if you're not running Docker, you may be used to using something called nodemon. Nodemon's a great way if you're developing locally to just have a node server running and it will restart itself every time you update your files. Nodemon's great if you're not in Docker. If you are in Docker, then you're going to need a different solution. So I'm proposing two solutions to you. The first is for our VS Code users. And don't worry, if you're not a VS Code user, I have a solution for you as well. There is an extension called Trigger Task on Save. Trigger Task on Save. And what this will do is trigger some task to run, any task that you define, anytime you save a file. So what we can do is we can create a task that restarts our backend service for us. And so every time we save a file in VS Code, this can restart our backend for us, which is great. So let us take copy extension ID. So I'm going to go in here to our VS Code Extensions directory, or extensions JSON file, I guess casing doesn't matter, and add this to our recommendations. So we're recommending that people install this. And now we want to add in a task. So if you go to debug here, this run and debug thing, this is where you run tasks in VS Code. And so we're going to define a task that we want to run, tasks.json, in our .vscode directory. So we're going to say version 2, which is the version 2 of this task specification, task spec, and we're going to build out our own here. So tasks is an array of objects. So let's make a label, and we're going to call this one restart backend. So this task is going to run, yes, a shell script that will restart our backend. So this is going to run a command in our shell of docker compose restart, and then you give it whatever you named your service. So since in our case, in our docker compose file, we named our service backend, then we put that here. Next up, we're going to set some options for presentation. We don't want this to show. Like, I really don't care to see anything, see any result of this task running in our terminal or output down here. So I really don't need to see anything. So presentation, we're going to say reveal never. So that won't pull up anything in our output. Okay, so that's configuring a task for us. I'm going to save that. But now we need to actually configure the extension. So let's go into settings.json, and I'm going to say trigger tasks on save dot tasks. Okay. And so that's going to trigger, we need to specify our restart backend task. So that's what we called it. And we want to restart that on any change of any source file anywhere in our source folder. So it's going to trigger this task name anytime we save a file here. Now, we can also, for VS Code's sake, we can set some excluded files. Let's see, I haven't seen some of those before. So we're going to set it to exclude anything really in our Git directory. So this just helps VS Code optimize what it is watching for. Okay, so if I go into source index here, and I say not hello YouTube, let's say hello Kevin. And I save very briefly down here, I don't know if you saw it, it said restart backend, and it had a little circle. So I'm going to say hello code. I hit save, restart backend right there. So it is restarting our backend in the background. Now, it looks like something exited from our Docker Compose here. That's lying to you. Well, it's not lying to you, but it's not apparent what happened here. In Docker Compose, when the log file's running here, we're only running one service. And when that service exited, when we restart that service, the old one exits. If there are no running services, then the log output just stops here. And it looks like everything stopped. It didn't actually stop. If I run a Docker Compose PS, we can see that it is, in fact, running. It's been up 40 seconds. So it's running in the background. So if I do a Docker Compose up, it will reattach to what is already running. And so if I open up localhost 5000 here and refresh a couple of times, you can start to see some logs come in. That will kind of resolve itself here in a second when we add a second service, so that your log output won't just stop and disappear here. But that's what's happening. If you run this and you're like, hey, it looks like it's stopping. It's not actually stopping. It's just restarting your log. Just stopped. All right, so that is option number 1 for how to restart, rebuild, rerun your node instance in Docker if you're doing VS Code. Now, if you're not doing VS Code, if you're doing something else, then what we can do is we can create a watch process that listens for any changes to your TypeScript files and then restarts your TypeScript for you. So one of my old friends has created a nice utility called Watchy. It's available in NPM, so if you do github.io/watchy, that'll take you directly to the GitHub repository of the NPM package named Watchy. You can see Mr. Casey WebDev here has created this package called Watchy. And so what this allows us to do is pass it a directory that we're watching and a command to run anytime anything in that directory is changed. And we're going to do a similar thing to what we've just done in VS Code here. So it's kind of a long command. So we're going to create a watch script here in our package.json. So let's run watchy. And let's say we're not going to do anything when we first spawn this process. And again, you can look at the docs here on the GitHub repo to see what all these things do. I assure you, I'm not doing this from memory. So we're not doing anything on spawn. And in fact, if a bunch of things happen all at once, we wanted to bounce our process here. So like, we're only going to run this restart of the backend once every second at most. So let's set a directory that we want to watch. So we want to watch our source directory. And then after 2 dashes, we can tell it what we want to do. So let's do a Docker Compose restart backend. So that will restart our backend. So what we'll do in this case is you can come in here. You wouldn't be in VS Code. In fact, let me not be in VS Code. So here in my not VS Code terminal, I'm going to run pnpm watch. It will be important for you to install the Watchy package. So let's do pnpm add save dev watchy. Excellent. Okay, so we have installed the Watchy process. Let's come in here and let's say, hello, people. And it has then just run Docker compose restart backend. It says everything's good, and it's once again watching. So whether you're editing code in VI or Vim or whatever else you're editing in, it will watch for any changes and restart the backend for you. So that's just another option for those who don't want to rely on VSCode extensions. That was one of the comments and feedback I got on last year's was not everyone wants to rely on VSCode extensions, which is totally cool. So that's one way you can do it. All right, moving on. What is next? So we've done Docker Compose. We're getting things back. We can see that this is working. Let's make sure we can debug. So let's say that something has happened here. Let's say we're hello from a variable that doesn't exist. So we're saving here. Our server's restarting. Let's pull this up. And boom, we're getting this error. And let's pretend we don't know what this error means. It is quite long. So we want to run a debugger here and see what's going on. So let's say I want to put a debugger call in here, and I want this to stop. But any amount of refreshing here, let me close some tabs. Any amount of refreshing here is not actually running my debugger. And if I just went into VS Code here and tried to run a debug, it's not really going to work because we're not running it on our local machine. We're running it inside of our Docker machine. So what we can do is make sure it is set up VS Code and our Docker for debugging. So let's go into our package.json, and this will be a good thing to put in our start Docker script. So first we're building, and then we're starting, but we want to start it with a specific flag. So instead of calling pnpm start, I'm going to just copy in what we have here under start because I need to insert a special flag here. So I'm going to say inspect. So this is going to enable debugging, and we want to enable it on a specific host, which remember for Docker, 0.0.0.0. So that is just going to enable debugging to be possible. Node is open to being attached to a debugger. So that fixes it or enables it for Node. Now we need to enable it on where we want to debug, which in our case is VS Code. So we're going to create again in our .vscode directory. You'll notice there's a lot of configuration when creating a Node project. I'm sure there, things like if you're creating a website like Next.js, boom, ready to go in like seconds. And there are, in defense of the Node ecosystem, several different app creator scripts to help you get going fast. But some are too bulky, some include a lot of things you don't need, some are too thin, they don't include things you do need. It is helpful to at least know what the pieces are. And if you have a resource like this video or the blog post or the GitHub repo, then you can kind of pick and choose what works for you. I actually use this exact setup that we're going over today when starting every single project. So there's quite a bit of configuration here, but what we've done is in our .vscode directory, we've created a launch.json file. And that is creating a profile for running our debugger. So it is communicating to VS Code that we're running a node debugger here. We're attaching to an existing process. We're not launching a new one. Our own name. This port, you might recall from being in our Docker Compose YAML of mapping that port over. To be honest, I don't know what restart true does. Remote root, we're telling it where the code lives inside the Docker container. We are using source maps. They're inline, if you remember, and we're skipping some files in here. So I've copied this in from the blog post to make that easy, but this is the magic configuration that helps us run debugging in Docker with VS Code. So I'm going to do Docker compose up. It's attaching to what was already running. So I'm going to Control-C out of that and it'll actually stop it. So I'm going to run Docker compose up again. And we can see that it says debugger listening. So it is listening for any debugging instances to come here and attach. So if I go to run and debug here, I can see that we've got our node Docker configuration that we've set up. So if I'm going to hit this little play, we are now server listening at port 5000. So if I come in here and I click on this and it starts loading in here, you see it stopped. Nothing's loading in here. And here in my VS Code, it has stopped here at debugger. So I can look at this request, that's the response. I can look at the request coming in here, seeing what this is all about. I can look at from variables, see what might be wrong with that. I can run commands in here. So, 1 + 1 is 2. We've proven that. You can run all your debugger stuff from your TypeScript file, by the way. The server is actually running JavaScript, but through the source map, you are debugging inside your TypeScript file for something that's not even running on your machine, it's running in Docker. So lots of layers here, but it's all working together nicely. And you can use the native tools here, even though you're running this in Docker. So I'm going to save that. I'm going to change this back to world here. Let's open this up. Let's refresh, and we're back to world. So once you get this configuration going, your development flow becomes very easy here. Look, I'm going to say hello world 2, save this. By the time I get to Chrome and refresh, everything's rebuilt, everything's restarted. It's a very nice dev flow. So that is how you get a debugging set up inside of VS Code and Docker. All right, moving on. What else do we have here? We haven't done any database. So that's kind of the last major piece to put in here and get working with our environment. So let me go in here. Actually, this is probably a good time to make a commit. Add Docker and express config, or not express, VS Code config. Excellent. Okay, let's go into Docker Compose. Right now, we only have one service, backend, but we want a database. And Docker Compose and Docker as a whole is one of the best ways, in my opinion, to run a database, because you can have several different databases on your machine. You can have several different versions of Postgres. Like I said, I work on a couple of different projects at a time, and some are on Postgres 14, some are on Postgres 15, some are on Postgres 13. And you don't want to have to be switching between Postgres executables or whatnot on your machine. So running these in Docker is very helpful. So we're going to create another service here, and we'll call it Postgres. And instead of build, because we're not building our own Docker image, we're going to use a pre-built image from Postgres, and you can choose whichever version you want. If you just did Postgres here, you'd get a version, probably the latest one. I'm going to go ahead and specify a version. So as of this recording, Postgres 15 is the latest version. When picking a Postgres version, it's probably best to go look and see wherever you're going to deploy this thing out, see what the latest version that they recommend or accept in their deployment environment. Then we can go ahead and specify Alpine here. So this is going to run Postgres version 15 on Alpine Linux, which is just a thinner version of Linux. Now let's say that you had a local local SQL utility or wanted to run pSQL locally to issue SQL commands, just some testing from your local Mac machine. Then you're going to need to poke a hole, add a port mapping between Docker and your local machine. And the default Postgres port is 5432. Very easy to remember, 5432. So we're going to map that from machine to machine. And there are a couple of environment variables that we will want to add in here. I didn't mean to do that. One is, though, PostgresDB. So Postgres_DB gives you the name of your database. So let's say node stack dev or web app dev. Whatever your project name in here is, that's what I recommend you call your database. And then I always add an myself, I always add an underscore dev, underscore prod, underscore staging, underscore test, whatever this is. So when you're connecting in your database, you have that reminder for which version you're on. It's very important. And then finally, there's a weird flag in here that you can see referenced in the Postgres docs on Docker, but there's this Postgres host auth method trust. This is just something you have to set in order to make things happy. You just have to do it. I'm trusting the docs in this case. Okay, the next thing is Postgres we really need running before our backend boots up and tries connecting to the database. You know, what if these try to boot up at the same time and Postgres isn't quite ready, but the backend starts failing because it can't connect to the database? How do you solve that here? Because by default, it's going to try to run everything in parallel. So we want to say that one thing depends on another here. So I'm going to add a depends on section here. I'm going to say depends on Postgres. So here under backend, I'm saying depends on Postgres. And what this will do is this will make sure that before it starts up the backend, that the Postgres service, or whatever you've named your Postgres service up here, is good and ready to go. So that means it won't start things out of order. And you can do that for all of your services in here. So if we added a Redis service in here that we happen to call Redis, then we could come in here and do that and make sure our Redis service is up before the backend service tries to boot up. Now, let's pass into, we'll want some way to connect to Postgres from Node. And it's going to need to know like the host and the username and the password and the database name and all that sort of thing. So what we can do is create an environment variable that has all of that database information in that Postgres, or that Node rather, would need to connect to Postgres. So let's add in a database URL variable here, and thanks to the magic of GitHub Copilot, this has actually guessed the correct URL here. 5432 is the default port, so I actually don't need that. So this is saying connect to the flavor of database Postgres, the user Postgres, at the Postgres host, and that's a very nice thing to have here in Docker Compose land, is every service name then becomes a DNS name. So when you're inside the Docker environment trying to connect to one service to the other, you can just connect to the DNS name backend or the DNS name Postgres. Just like you would google.com is a DNS name, you can connect to just Postgres, and that will can't think of the word, that will end up resulting in this Postgres service. Throat's kind of dry. Then the /webappdev is specifying which database to connect to. Okay, so yes, Daniel, that is exactly what I'm looking for. Excellent. I didn't see when you put that comment in, so I don't know what you're saying you were looking for, but I'm glad you were able to find it here. And Jose says, is it not easier to create a volume? I'm not quite sure what you mean by that. So maybe if you could specify it further, I could help answer that. So we are passing an environment variable that will now be added to our backend that we can use to connect. So in our Node environment, how are we going to connect to Postgres? I freaking love Prisma. Love, 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 love Prisma. Can't say enough good things about Prisma. Prisma is a fantastic ORM for connecting from Node, especially in a TypeScript environment. It really helps to have TypeScript types for your database. And especially when you're dealing with nested objects or updating relations of objects and coming up with finder and where conditions and what all the conditions could be based upon the data type, Prisma has very rich types for connecting to the database. I really love Prisma. So we're going to use Prisma here in this example as well, of course. Let's install Prisma. I'm going to go to our terminal here, delete a few of these. Let's do a npm add. First, let's save dev Prisma. So Prisma has some interestingly named packages here. One is called Prisma. What this really is the Prisma like CLI. It's the Prisma command line interface for using Prisma here. Now, inside our project, we're going to need the Prisma client, which it actually generates on demand. We'll go over that in a second. So let's do npm add not save dev at Prisma / client. The other one did not have at Prisma. So we have now just added two things to our package.json. One is an at Prisma client to our regular dependencies, and to our dev dependencies, we've added just simply Prisma. Now we can do a, you might be used to npx to like execute things. We're going to do pnpmx, Prisma init. What this will do is it will use the Prisma CLI and initialize the files we need to set up Prisma in our environment here. So let's take a look at what happened here. First, we're going to delete something that Prisma was trying to do to be helpful and did not. So let's go see, it created a .m file, which is very nice of it. Thank you, Prisma. We really appreciate it. We don't need this. Since we're doing this in Docker Compose, we're already setting in the database URL environment variable. That's not something we need. So I'm deleting the .m file, env file. But what is helpful is it created a Prisma directory. And inside of that, it created a file called schema.prisma. If you've never used Prisma before, it has this DSL, it's a fancy word for its own language, domain-specific language, for representing your database model, okay? So here in the Prisma file is where we might put a database model. We're not going to like actually build a full-fledged app in this video, so we're just going to do kind of a sample here. So let's say we were doing something like blog posts. Actually, you know what? We're going to do that one at a time in case you haven't done this before. So let's say that we are creating blog posts and we want to set up the columns and types for all this. So let's do this one at a time here. So post, the first thing we want is an ID of this column. So I'm going to say ID. There are a couple of different IDs you could use here. You could do an integer that auto increments, as GitHub Copilot suggests here. I love strings as IDs, and I specifically like generating shorter strings from a specific library. So I'm just going to say string at ID, okay? So the first item is the column name. The second item is the data type. And the third item is any sort of like attributes that this is. And so this is just telling Prisma that this is representing the primary key ID of this model. Next up is the slug. So if you have a blog post, you might want, like fancy URL. So we're going to say that this slug is a string and it's unique. Now, if you have a Prisma extension installed in VS Code, every time you save this, it will auto-format your file for you, which is super nice. So let's do string slug, and that is unique. So it's expecting that we have a unique index in the database. Next up, let's say that we have a title, and that title is a string. It's neither an ID nor is it unique. It doesn't have to be unique. So then let's say we have content, and let's say that this is a string, but let's say that this is optional. So we're going to add a question mark here to specify that this is optional. Why might this be optional? So let's say that we want to allow creating draft posts in this database. So we would say that a slug is required and tiles are required, but you don't have to write the content up front. So the question mark here describes that this is optional. So then let's say we have a published at, and that is a date time, so timestamp essentially, and it is also optional. So if it's null, it's not published. If it is present, meaning that it has a date time in it, then it is published. Then there are two nice to have columns that Prisma can help manage for you. So first is created at. And so created at is going to be a date time. It's required, but we're making it giving it a default value. So it's by default, it's just going to insert the current time. Then next up is updated at. So it's also going to be timestamp, also required. And then this special updated at attribute or decorator, I'm not sure which they call it here. This is going to be managed by Prisma for you. So anytime you update a record, you don't have to manage this yourself. Prisma is going to automatically update this timestamp for you. Then finally, we want to tell Prisma what this is called in the database. So what I like to do is I make my models singular and I make my database tables plural. So we have a posts table, and then anytime you pull from that, you get a post model. So if I hit save here, then that looks good. But because Prisma utilizes Typescript and it creates custom types for all of your models that you have in here, Prisma needs to generate its own library specific to your project. So for that, we're going to run a pnpx Prisma generate. So that is going to generate a specific client for your specific project for your specific models. So what this really needs to be, this really needs to run kind of like when we're installing our dependencies, which is an important part of this setup. So let's go ahead and do that now. So our Dockerfile, when we're installing our dependencies here, that's installing everything, but we also need to generate this Prisma client. So under this run and before this copy in of everything, I'm going to add a few lines in here. Again, when you're doing steps in your Dockerfile, you want to do the minimum required changes so that it can cache as much as possible. So I'm going to copy in this Prisma / schema.prisma file, and I'm going to copy that into the Prisma directory in Docker. Then I want to run pnpx Prisma generate. So just like we did locally here, we're going to run that in our Docker anytime we're building this image. So that is important to know. If we change the model here, that does mean we need to rebuild our Docker image so that we can get a new client. Now another option here is maybe you could add this to the build script and it builds every time you start up the Docker server. That could get a little slow. You change your Prisma schema infrequently or more infrequently than you might other code. So I like putting it here in the Docker file because that's something we can rebuild manually as needed. All right. I did mention earlier briefly that if I save this, it reformats the file for me here in Docker Compose, not in Docker Compose, in VS Code. That does come from a specific extension. So I'm going to add that extension in here, and that's just prisma.prisma. So prisma.prisma extension will add the Prisma language and code formatting in here for you. All right, so I think that has our database in here. We're not connecting to anything in the database yet, so let's go ahead and do that. Although we want some data in here, but we don't have any database tables either. So that means we need database migrations. Opinions coming your way, okay? You have two options. One option, well, you have a lot of options. One option is Prisma. Prisma has Prisma Migrate. Great way to handle migrations. It does cut down on the code. So this Prisma schema that we just spent time creating, it will actually generate for you the migration SQL necessary to create these tables and do this sort of work. If you want to do this, that is a great option. More power to you. No one would blame you. And in fact, most people would probably clap and pat your back. For me personally, I simply love Knex. I love Knex. I love Knex's migrations. So Knex itself is actually a whole ORM, like Prisma, but it does not have all the features of Prisma nor the TypeScript power that Prisma has, but it does have a great migration utility. And the difference here is that Prisma runs your migrations from SQL files. Knex runs your migrations from JavaScript or TypeScript files. So if you're doing things in JavaScript and TypeScript, you have a bit more flexibility to script things out, to run things through JavaScript when you need to. And that's just something that I've personally found helpful in the many apps that I've worked on. So I like using Prisma for my ORM and Knex specifically for migrations. So let's add in a bit of Knex here. Let's go in here and we'll say npm add Knex. And we also need to add the driver for which database we're using, which is Postgres, which is just the PG package. Now, in order to use Knex migrations, we also need the utility tsnode, which helps run TypeScript files quickly and easily via node. So let's do npm add --save dev ts-node. After that, we do need, you guessed it, some configuration. So I'm going to add in a configuration file called the knexfile.ts. And this is going to help us tell Knex what to do. Now, one of the cool things about this, actually, is that you'll notice this is TypeScript. So I do like that Knex does this. We're actually going to say, we're going to make a config file, and we're going to type it to Knex config, which is super nice to have types for your configuration. Who would have thought? So we're going to tell it what type of database we're running, which is client PG, so the Postgres package. The connection, we want it to get from our environment variables. So we want it to pull from the database URL environment variable. Once again, that's being set through our Docker compose file, telling it how to connect to our Postgres database in Docker compose. And then the final thing is when we're generating migrations, we want to specify the extension we want. So we want to build TypeScript migrations, not just JavaScript migrations. So then finally, we'll export this config as the default, and that concludes our Knex config. So now we can use Knex to create an initial database migration. So I'm going to run pnpx Knex migrate make, and then whatever we want to name this migration. So I'm going to call this initdb. So this is just kind of a helper utility to add in a migration file that is timestamped. So if you come from Rails world like me, I haven't done Rails in like almost a decade. If you've come from the Rails world, Rails had a very good way of doing migrations, and Knex kind of follows that method. So we've got a directory of migration files that all start with timestamped file names, and we have up versions and down versions. So if we're migrating up to this version, which is we're kind of migrating forward to it, this is how you would add columns, change things. If you're migrating down, that's usually how you would like undo it. So we can do this. Now, this is the criticism that people would have for you if you're doing migrations through Knex and you're at the same time of using Prisma. It's like, why not just use this? It's like you're coding it twice. You're correct. It is like you're coding it twice. But this is for the initial set. I have found working with apps over several years at a time, things change so much. Your data model is always changing. And so for me, in my opinion, again, it just does help to have the scripting ability. I don't mind double coding this the first time through. It doesn't bother me. So I'm going to double code this. I'm going to start so we're going to create the up version of this. So we're going to create a table called posts. And the nice thing about having Copilot here is it often does help you out with what you need. So the first thing I'm going to do is the ID column. Now, we could say string, because we're doing string and ID in primary, and that would be decent. Not the best. String in Knex is a varchar, so that means a variable length string. In our case, we're going to use a package called nanoid to create very specific lengthed strings. So every single one of our IDs is going to be a 16-character ID. So I'm going to say specific type here. The column name is ID, and this is going to be a char of 16. So this is not a varchar, not variable, just a char of 16. So it's specifically a 16-character ID. Next up, we're going to do we do need a title, so thank you for that. Not nullable, so it is required. We do also want a slug, though. So that is also not nullable and unique. So this .unique thing, we'll go ahead and add in the unique index for us. So now let's do a text column for content. And this is going to be nullable. They do have a nullable helper here. It doesn't do anything. These are nullable by default. So that's good. Then we'll do a table.timestamp published at, and this can be nullable, so that's fine. And then we'll do and you know what? It's probably best to go ahead and put an index on that, because when you're querying for your posts, you're probably going to order them by published, so it'd be helpful to have an index on that. I don't have that in my blog post. I should add that. And in that case, actually, we do want to add an at index here. No, okay. That comes down here then, at index. And we're going to say we're indexing published at. So this is saying that there is an index on published at. Just kind of helps Prisma out. Okay, next up is our other final timestamp. So timestamp created at. We're going to default this to now, say that's not nullable. And also our updated at timestamp, we'll default that to now also, and that is not nullable. Now, the beauty of GitHub Copilot is that it almost 100% of the time, 99% of the time, writes your down migrations for you. So I know that's a little bit of duplication. Doesn't bother me because these drift over time anyway. You'll find yourself writing quite a few migrations. Okay, so we need to run this. Let us first get our backend going. We made several changes to our Docker file here in generating our Prisma client. That means we need to rebuild our backend. So if I just do docker compose up, that is for some reason like rebuilding here. Oh, that was, if I just did docker compose up, I'm like, why is that rebuilding? It's not rebuilding. It is pulling in the Postgres image because we added the Postgres service. So it pulled down the Postgres image version 15 specifically for Alpine and ran all of these things. It did not, however, rebuild our backend for us when we do need our backend rebuilt so that we can get the Prisma client in here. So we needed to go through a couple of things to rebuild our backend here first here. We're going to do this manually, then we're going to create something, a helper script for us. So let's do docker compose build backend. So that is going to issue, tell Docker, hey, let's rebuild the backend. So it's going to go through here, and if we're lucky, and we are, it will generate our Prisma client for us. Excellent. So now let's say Docker compose, we want to remove, and I'm going to say force, and I'm going to say stop if it's running, any sort of backend containers that are running right now. So remove those. So now let's do a Docker compose up again, and it's going to create a new backend running container with the updated Prisma client that we added in here. Now that's a lot of commands there. We're going to add in some helpers in just a second to do that. Now let's run our migration. So even though our database is present, we don't have anything in it because we haven't run any migration. So I'm going to open up a second terminal here over here and run that as well. So I want to run some migration. I want to run them inside of Docker. So I'm going to say Docker compose. And I'm going to say run something in backend. And what do I want to run? I want to run pnpx Knex migrate latest. So this is going to start up a container of a backend, run with Knex migrate latest, and it says batch one run one migration. So it ran our one migration file to migrate our database up and create that table for us. Now that's a lot of scripts to be running. Seems like a lot of work. So what I always do is in package.json, I end up creating quite a few scripts in here that really simplify your development life. So I'm going to add in a few here that you can copy in from, again, the blog post. And that's going to make our life happier. So again, I come from the Rails world like a decade or more ago. And so those Rails scripts are burned into my head, like, Rails DB migrate, things like that. So I kind of bring those into my node environment because I like those. So pnpm db migrate will run that next migrate latest command. But you often don't want to run it just locally. You want to run it inside of Docker. So what I do is I create a Docker db migrate command. And that runs very similar to this command that I have in here. So Docker compose run back in pnpm db migrate. Let's say you make a mistake and you want to run the down commands in Knex to undo just like one migration. Then we have an undo script there. And then anytime you need to rebuild your backend, so like let's say I come in here to Prisma and I'm like, I added this index. Now I need to rebuild my backend. There are quite a few steps to go through and do that. So I always create like a rebuild script in here, and then I shorten back into just BE. And that runs all the different Docker commands that we need to rebuild our backend. So let's run that here. So pnpm rebuild BE. And I run that in a separate terminal, and that will rebuild the backend. And as soon as it's done, it's going to stop and restart the backend here. And you can see that happening on the left, and we're ready to go again. So, you saw a second ago, there's a lot of commands to type in, but that was very simple. And so if this seems like a lot of work, it's really just work setting up. Once we have this going, the development flow here is really nice. So that's started here. And when our backend stopped, you'll notice our log didn't stop because we also have Postgres running. So we don't have the issue of our log stopping and starting here either. All right, so that means we now have a database table. And in fact, I have a script here called dbconsole. So let me run pnpm dbconsole. And that gives, let's see here. Let's do Postgres. Looks like my script is wrong. My script is wrong. Remember to correct that in the blog post. Okay, so now I'm connected to a Postgres console. If I just do a /d, that will describe the tables here. So I can see I have a post table. And so I do, in fact, have the post table in here ready to go. But if I do a select star from posts, I have no posts. What's really helpful in development is not making your developer, or you, constantly be creating a manual mock data. So what would be nice here is to create a seed file that would allow us to seed our database, to populate our database with mock data anytime we need it. So let's go in and create a script that will seed our database with some data. And then this will be the first time that we see that we'll be using Prisma here to read and write data from the database. All right, so what I like to do is create a scripts directory. So scripts/seed/dev. So script/seed/dev.ts. And I want to write to the database. Now first I need to connect to the database. So what I also like to do is create a source/modules/db.ts file. I'm going to pull those side by side here. So I have a DB module on the right and a seed script on the left. So on the right, I want to create a Prisma client using our custom Prisma client that we can use to connect to the database. So I'm going to say const db equals new Prisma client. Now, if we were lucky, that would auto import for us. In this moment, we are not lucky. But we can GitHub Copilot this and import Prisma client from @Prisma client. That is correct. Now we can pass some configuration here for me, especially for development mode. It's helpful to see all of the logging. Like I want to see everything that's happening with the database, every query, every error, everything. So you can come in here and specify what you want to log. They have 4 different log levels. I say take them all, especially for development. You can end up changing this for production if you would like. So I'm going to export this little db variable we have as default, which is nice. Now, generating IDs. You could do database generated IDs. You could either do auto incrementing integers. If you do that, do big int, not just regular int. If you don't know what that is, Google big int and definitely always use big int for IDs. Or you could do UUIDs, universally unique IDs. Postgres can also auto-generate those for you, and even Prisma has the ability to generate UUIDs. I'm blanking on that right now. You can Google that. Prisma does. I like generating my own IDs in JavaScript. I know that might be weird, but that's how I do it, and I really like it because I can say I want this specific length of this specific type. And in order to do that, I use a cool little library called NanoID. To me, UUIDs are long. They're kind of ugly. So I like shorter IDs that you might see in like Instagram URLs or things are, Google Docs has awful UIDs. They're like super long. But shorter IDs that just look nicer. You like nice looking URLs, right? Okay, so I'm going to come in here and I want to install this package called pnpm add nanoid. All right, so now I'm going to say I want to create a helper function called genID, so generate ID. And this is going to be a function that takes nothing but calls nanoid. And we're going to pass it a variable to say we want an ID of length 16. So we always want 16 character ID. Once again, we're not getting lucky on nanoid here. Okay. Oh, we're going to fix a problem before it happens, okay? So nanoid, I happen to know from trial and error that nanoid version 4 is only for ES modules, only. If you are not using ES modules, which we are not today, we're going to use version 3. So I'm going to say pnpm add nanoid at 3. So we install the latest version of version 3, and so that's going to change that to version 3 for us. Muy importante for nano ID. Okay, so I'm going to export that as a helper function from this database module. Now we've got a nice little setup here for interacting with the database that we can use in our seed script. So I'm in our seed script over here. I'm going to say create a function called run. It's going to be an async function. That's good. And so when we run this, we want to populate a few posts in our database. So I want to say await db, db, and it would be nice if it imported it. It does not. So let's do db from source modules db, yes. Post, so it is pulling this from our Prisma schema and completing nice TypeScript-friendly types for us. So I'm going to create not just one, I want to create many. So I'm going to create a couple of different posts for us. And so if I do control space here, I get nice TypeScript autocompletion. So data, that's going to be an array, I happen to know, of objects. And then I get a key for every single one of our values here. So ID, I'm going to run a gen ID. Slug, let's say ultimate node stack is our slug. Our title is ultimate node stack 2023. Let's say we do have a published app. And let's say that that is today. So we're just like right now. Whenever this is running. So this is an example of a published post. Now, nothing that is optional I'm going to put in here. So we're not putting created at or updated at. That's being handled through Postgres and Prisma. I'm also not putting content. You know, probably if you're publishing a post, you probably want content here. But for mock data at this time, I'm not going to put that in. So let's now do one that is not published. So let's generate an ID. Let's do a slug that's called maybe draft post. And then the title's draft post, but I'm not going to put in a published at timestamp. So this one's going to have a published at of null. Now this is a TypeScript file with just this run function. It's not actually being run, but we want to make it runnable. So there's this like fancy way of, if you're calling node in a specific file, knowing that that file was the one that's called and running a function. So this might make sense. So if require, again, this is something you don't do very often. I certainly wouldn't be able to do this from memory, so I look it up each time. But this is saying that if require.main is this current module, meaning like this is the main module that node is doing, then we're going to call run here. And then we're just going to output a nice little message to us. This is nice, and we're going to say data seed complete. So this is going to auto run when called directly. Okay, so now let's create a little script in here for running this sucker. So I like calling this seed dev, and this is going to be a quite a command. So we need to run this in Docker. So start there. We're using Docker Compose. Okay. We need to run this from the backend instance. So anytime you're running something in Docker Compose, you can either use exec or you can use run. Exec will execute something in an existing running container. Run will create a new version of that container temporarily just for this job. I'm going to use run in this case. So we're going to run a version of the backend container. And the script we're going to run is pnpm ts node scripts/seed/dev.ts. So through this lengthy command that we don't have to remember, we're going to seed our database. So let's see if this works. pnpm seed dev. Okay, blew up. Let's see where it blew up. No nano ID. So because we did update our packages, we need to rebuild our backend instance. So we'll run our rebuild BE. That's rebuilding. It's cached a lot of the steps, so it's going to be fairly quick here. Okay, that rebuilt. So now let's run our seed dev again. See if this runs. Okay, it did run. And we can see, because we're logging everything, we can see the insert statements that did happen here. I'm going to just, for kicks, run our DB console here. And we can come in here and say select star from posts. And we can just see that, in fact, we do have posts in here. Great. By the way, yes. That's a nice little tip for you. If you're short on space in the Postgres command line utility here, you can do \x/auto, and that will enable expanded display. So when something looks like this, it's like near unreadable, it will convert, instead of into this visual table, into this like vertical records that makes it easier to see your records here. So we can see our records here. We can see our nice 16 character IDs. We can see everything going on. That's great. Okay, so now we have a database. We have migrations. We have tables. We are connecting to the tables. We're inserting data. We have a seed script that we can run anytime we need to seed data, but we're not using the data. So let's use the data in here. So let me go to our index file. And in here, instead of returning like just plain old JSON or hard-coded JSON, let's actually fetch our posts. So let's say posts are await db. That will auto-import for us, thank you. Post.findMany. And we could like find many that are, in fact, let's do that. Let's find many only where published at is not null. So we're only looking for our published posts. So published as is null, we don't want those. Now, in order to do await, this needs to be an async function. And now that we have this posts variable, we want to return that as our JSON. So if I save that, it will restart our Docker for us. If I refresh, then we get our JSON, and we can see there's only one object in here, which is our published post. Voila. So how was that? Did that make sense? I know this has been like 2 or so hours. Hopefully, if you're watching the recording, you just skipped on over the Docker issues. We got those fixed. But this has been from scratch all the way through how you would set up by hand a full or a complete node stack with Postgres, Docker, Node, TypeScript, ESLint, Prisma, Prettier, Knex migrations, restarting, Express, everything. Database seeding, lots of helper scripts to go along the way, everything. If this seems like a lot, you're correct. It's a lot. It is a lot to get started. And if you didn't have like a guide, like this would take days or more. Thankfully, this is a one-time setup. You can reference things like this video, or like I said, the GitHub repo to get going started, to get going quickly. But once you have this in, once you've got this set up, your debugger's working, you've got automatic restarting, you've got all of your helper scripts to make things super easy for you. Once you've got this going, it ends up being a really nice development experience. And as you grow your app, as you need to expand your app, like let's say you needed to add Redis, that's going to be a couple lines here in Docker Compose. And because you've already got a Docker ecosystem in here, you can get going with that. Once you're ready to push to production, you're going to be a lot closer because you're already used to connecting things on different hosts and ports. By the way, I have a full stack build video if you're interested in that, which is similar to this, but it starts at this point right here. It starts from our ultimate node stack, and it adds on what you would need to deploy to production. So if you're ready for the next step now, definitely check out my full stack video app, and that will show you how to add in Redis and how to get all of this pushed up to production on one of my favorite hosting platforms called render.com. So that's a great next video to check out. Like I said, this is all in a blog post. You can reference it here. It's linked to in the description of this video. There's also a companion GitHub repository for this called Mr. Wade/Ultimate Node Stack, where you can reference this exact state of the world of code here. And like I said, I and some team members here manage several different apps, and this is the basis of all of our apps. And this is kind of the setup that we've perfected and we keep tweaking year in and year out. You know, like PNPM was new this year. Eventually we'll do ES modules, we'll get there. Something I've added interestingly in one of our recent apps is full integration tests that use a separate like Docker Compose stack for doing end-to-end integration tests with a dedicated Postgres test database and Node and all that. That's actually working quite well. That even runs in GitHub Actions, so maybe I need to do a video about that at some point. But please, if you found this video helpful, consider giving it a like, consider subscribing to my channel. I hope this was helpful for you. It's been a lot of blood, sweat, and tears over the years to figure out kind of how this sort of configuration comes together. And if you have any tips for your fellow devs of alternatives or different things that you might do, feel free to leave those in the comments below. But other than that, I hope you enjoyed this, hope it was helpful, and I will see you in the next video. Have a great day.